All right, can you see my screen all right?
Yep, looks good.
Okay, yeah, so yeah, let's get started talking about what's coming in Kong Gateway 2.2. Well, for those of you who follow our GitHub and see what's going on in our next branch, this is not going to be a lot of news because it's the nature of open source. So everything that's coming, like that's already been finished, it's now there. But yeah, so I hope there will be still a few surprises and interesting stuff for us to discuss here. Okay, so I will be presenting. I'm product manager for the Kong open source gateway at Kong. And we'll have also a demo by Datong, who's one of our systems engineers in Kong's core team. And this presentation is going to be pre-recorded because Datong is based in China. So let me start with a little bit of a year in review. I started the same way when we were talking about the Kong 2.1 release. So it's good to put things in context. So over at Kong open source project, we've been like busy, hard at work, pushing lots of releases through the years. And everyone must have noticed that we've had a very long cycle between Kong 2.0 and Kong 2.1. And now that we are within the 2.1 cycle, we already have a number of patch releases in the past month. So this is how the year has looked like in terms of stable releases. If we expand that to include the pre-releases, this is more like how the year has looked like. So 2.1 has seen a really long cycle in which we have like really essentially as we release a stable version, we already have like we push the next branch becomes the master. As it becomes the stable, then the next branch is already like free to get new features that will land in the next release. So basically, Kong 2.1, which was released in late July, was the culmination of all of the new stuff that we were worked on from January to July. So that was pretty long and unusual for our cycles. If you will remember, the Kong 1.x series last year was more like 2 to 3 months between releases. And we want to get back to that cycle. Now, this long cycle for 2.1 had a lot to do with our resynchronizing our release schedules between the open source project and Kong Enterprise, which includes the Kong Gateway. So the idea for that was to actually to be able to speed up both projects by doing that. So now with Kong 2.1 having been released late July, our goal is to get 2.2 Alpha 1 later this week. So and then after that, we want to do a beta and then an RC series. And we definitely don't want it to take as long as 2.1 took. We want this to be much shorter, much in the style of the 1.x releases. So you should expect Kong 2.2 Alpha coming out now-ish, like this week. And the beta like less than a month, and then that, and then we get to RC like less than a month after the beta. So that will put us back into 2 to 3 month cycle that we have been seeing before. So yeah, so as I said, like a lot of the stuff that's going to be in 2.2 Alpha, you can already play with it right now if you want to be in the bleeding edge and get a branch out of GitHub, right? Because we are an open source project, which we are developing that in the open, and you see our PRs coming with the new features. And I want to start about talking a little bit of that, like the features that are already in. And yes, I'm going to talk a little bit about the stuff that's also to come. So yeah, one of the big changes that we'll see is that Kong 2.2 will bundle OpenResty 1.17.8.2, which is in itself based on Nginx 1.17.8. And that includes, I'm not going to go into the details here, but that includes like tons of bug fixes, features, optimizations. The OpenResty package also always gets the latest commits in the Luajit development branch from Mike Paul. So optimizations on the Luajit side there. So it's a general improvement overall. whenever we get to bump the OpenResty version, which we choose to do when we switch miners, and their release cycle matches ours. So I will share the presentation, and we'll see in this link, we can go through the changelog of OpenResty and see the full details for that. Next thing, I want to give a heads up that in starting Kong 2.2, we will be deprecating support for Cassandra 2. In practice, in terms of code, nothing changes for now. The Kong 2.2 will still work with Cassandra 2.2, but this is a heads up to that by the time of Kong 3.0, the support will be outright removed. And it's a good time to be deprecating it, because Cassandra 2.2 will be end of life by the time 4.0 is released. I mean Cassandra 4.0, and Cassandra 4.0 beta 2 is already out. So the release of Cassandra 4 is imminent, which means that Cassandra 2 will be end of life, and it doesn't make sense for us to keep supporting it. The good news is that this will probably not affect any of you, because from the metrics info that we get, basically nobody who is running Kong 2.x, like who is running recent conversions, is still running Cassandra 2, like at least from the stats that we get. The only people that we see running Cassandra 2 are running very old versions of Kong, and well, they should probably upgrade both of them by now. So yeah, now talking about features. There's one open PR that we hope to get merged. It might have been merged. It might be merged like as I speak here, for all I know. But we have the code pretty much ready for adding response handling for Go plugins. And what does that mean? That means that Kong plugins are built around the concept of phases, which mirror the OpenResty and Nginx phases. But essentially, that means that you have callbacks for access phase, or in Lua, you have header filter, body filter, which means like the processing of the incoming request in access, and then the processing of the response coming from the upstream service. And header filter, you can process the headers. Body filter, you can process the body. And this is very aligned with the way that the Lua functions in OpenResty work. And that would not make sense to replicate in our Go support, because that would take a lot of back and forth between the Go server and the Kong process for it to be usable. So what we're doing instead, so in our first version of the Go PDK support, we only had support for access, log phases. Like you could handle the request, but not really manipulate the response. Now we're adding support for manipulating the response by buffering the upstream response on the Kong side, and then running an all-in-one phase, new phase called response, which allows you to modify and manipulate both the headers and the body at once. So it supports things like new APIs like Kong.response.getBody, where you can get the body of the response, and also like read the response headers and set the response headers and do all of that. As a bonus, and in order to get consistent PDK APIs across the board, we're also adding this response phase that automatically does response buffering into the Lua PDK as well. So you can also use this new response phase instead of the filter phases. You can use one or the other, and if you use the filter phases, then your responses are not buffered, and you get like streaming, and it's higher performance. And if you use response, then the response is buffered with all that entails. But then you can do things that you cannot do with the filter phases, such as modify a header based on the contents of the body, right? Because in the filter phases, the header filter runs first and the body filter runs next. So here, since we buffered the entire response in the response phase, you can modify both at once. So another major thing that was just merged into our next branch, and we'll be featuring in 2.2 already in the alpha, will be Udp Support. This is a big feature, and it's important for Kong's mission of supporting like all kinds of data in flight. Now, this will complete at this point. We'll have HTTP, HTTP2, gRPC, and TCP, UDP. So in this first stage of development, what we'll have is an introduction of this feature. Will have support that's similar to Kong's TCP support. What that means is we'll support for proxying as usual, load balancing, and plugin support. And mostly for plugin support, that means at first logging, because given the nature of the API gateway, most of the plugins assume or only make sense in HTTP environments. But for things like UDP, you can do login support. And for that, we will proceed with a demo, which, as I said, is pre-recorded. And we'll hear Datong talk about the incoming UDP support. And this is another, I think the sneak peek of the next Kong version is sort of a first for us here in the online meetups. And I think another first is that we're going to give you like an inside look at how things happen in Kong's development. Because this video was actually not prepared for this demo. This was one of our internal engineering demo sessions that we hold regularly inside the company, where all the engineers, as they develop the features, they present to the other teams the cool stuff that they're doing, right? So this is a presentation that Datong prepared to be presented internally at the company to show the other teams about UDP support. And we decided to, hey, why not just share with the community at large? So without more further ado, let's hit play and watch Datong's presentation.
Hello, folks. In this video, it is my honor to demonstrate the Udb proxying feature that we have recently developed for open source Kong that is scheduled to be released in the upcoming 2.2 release, which I believe the alpha is actually coming out next week. So it should be available for testing by everyone pretty soon. But I just want to give everyone a taste of the feature as of the current stage. Before we go deep into the demo, I just kind of want to mention briefly that the goal of this feature, at least at this stage, is to get it out and get a taste of how users are using it before investing heavily onto it. So we added basic proxying support, some plugin integration and load balancing support, at least for 2.2 release. We might be adding more features such as health checkers and so on in the future, but that's not going to be coming in 2.2 yet. So without further ado, let me jump straight into the demo. So I have 3 demos here to show you. So the first one is a pretty basic Udb proxying demo. So I have a declarative config here. So if you take a look at this file, it is pretty simple. It's just proxying onto the localhost 7000 port using the Udp protocol, which we added in the 2.2 version. And then for the routes, it's basically the same as a TCP proxying route, but the protocols is actually Udp. So this actually works as you would expect. So let me actually demonstrate this for you. So in order to run this, so you need the Kong string listen, and we added the new Udp flag onto the listener. So this would actually cause Kong to listen onto the 9999 port on the local host, but the listening protocol will be Udp instead. And the Udp and TCP ports could coexist on the same port. They don't interfere with each other. So if we actually start a Kong like this, as you can see, that Kong is actually indeed listening on this port with the Udp protocol. So I just need to start a local Udp server. So the easiest way is just to use netcat, and I'll use the listening flag and Udp flag. So on port 7000. So now I can connect onto that port, actually connect onto the Kong proxy port. So I can specify that it's in Udp mode, and then the IP address is localhost, and then we connect onto the string listen port. So this is the 9999 port. It's not the 7000 port for the upstream. So if we connect onto that and we type something, as expected, it does work back and forth, right? So the Udp packets are being shuffled between the backend, which is here, and the downstream, the client, which is here. And Kong is just acting as the middleman. So some of you might be wondering how this would actually work, because we know Udp protocol it does not have a concept of connection and stream. So how do we actually proxy this kind of protocol? So we're able to proxy Udp based on the fact that the majority of the Udp protocols, Udp-based protocols, I would say out there, are designed on this principle. So say you have a client A, and it uses the source port 123 to send a Udp packet to a server B. Let's say the destination port is 456. So if a Udp packet was sent from this port to that port, then typically I would say 99% of the protocols out there, when B is sending something back to A that's related to this transaction, it would actually send it back to the send port. This is not necessarily required for Udp. I mean, technically, B could send the response to any port. Like it could actually send it to 124 if A chooses to listen on that port. But majority of the protocols out there just sends the packet back to the original port. So that's actually how this proxying actually works. There's technically no concept of a string in Udp, but because of this port consistency between related packets, we were able to kind of guess which one of them belongs to the same stream and try to proxy it like that. So I will show you another demo next, which is one with a logging technique. So let me look at this file here. So in this file, it's all the same thing. What we added is that we enabled the file log plugin onto the example service, and we write the log onto the temp file system. So in order to demo this, we actually don't even need the upstream because even if the packet is lost, the logging plugin will still be fired because, like I said, especially in Udb, because it doesn't really have the concept of a connection being established, and it doesn't really care whether the packet arrives or not by the protocol's design. So if we actually restart Cone with this declarative config instead, and then I just simply send something onto that port. And then, the upstream is actually not running. So this actually goes to nowhere. But if we actually look at the log file that we specified, you would actually see that Cone indeed wrote some logging entry onto the file system. So as you can see, a couple of things interesting here. So the protocol is obviously Udp, that's expected. We have the session. So the session in the layer 4 proxy mode for Cone is basically the same as the HTTP request, and it also has a status code. So this is not a real status code, it's just relating the L4 status to the HTTP status, so it's easier to understand by people, and this is actually done by Nginx. You will actually see that despite the upstream not being running, the status is still at 200, which means that Cone thought that it did its job and successfully proxied the packet, which it indeed did, because like I said, the Udp protocol doesn't have the concept of a connection. So even if the upstream is down, we would still consider that proxy was successful, even if nobody else was listening for the packet, right? So that should make some sense, I hope. And the third demo I want to show is the load balancing support for the Udp. Which actually, I guess it probably makes this feature a little more useful. Without the load balancing, I doubt anyone is actually going to want to try this. So this is still the same, except that the services is now passing on to a upstream. And then this upstream is using a round-robin load balancing algorithm, and it has two targets. One is on 7,000 and one is on 7,001. So if we actually spin out two netcats on here, so one is listening on 7,000 and the other one is listening on 7,001. And then let me restart Cone with the LB config. What would actually happen is that the first time you send the package here, it would actually go to one of the upstream, and then the next time you send it, it would actually be load balanced onto another upstream. So I will actually show it to you here. So if I hit hello, you see that hello actually showed up on 7,001, and this actually works because, like I mentioned about, because of the port number assignment. So if this upstream response, we still know where it should go back to. So if there are more packets from the downstream, if I say more packets, it will still end up on the same upstream. So it's not actually going to randomly bounce between those two, because Cone knows that this source port should always go to that upstream for this IP address, right? So this is the session consistency that we're talking about when proxying Udp protocol. But if we actually kill the client here and then we rerun the client again, and then now we send something else, you would actually see that now it's actually load balanced onto the 7,000 upstream. Why? Because when we respawn the netcat client in here, the source port which netcat randomly chooses to connect to Kong changes, and then Kong would actually consider that from a separate UDP transaction, and then it will actually rerun the load balancing algorithm. Right? So likewise, if you respawn here and it will go back to here, and if you keep writing something, it will still end up on the same upstream. It will never go here unless you kill the client and the source port changes. So I hope this all makes sense. Obviously, I wouldn't be at the meeting to take the questions, but I do think there's one thing that people might be curious, is that how long do we remember this port mapping between the client source port and the destination? So that's actually not something that we do specifically. This is actually done by the Nginx string proxy module. If you look at the documentation, there's a directive called proxy timeout, and it's set to 10 minutes by default. So this obviously works for TCP mode, but for UDP mode, we will actually remember that mapping between the client source IP and the and the upstream for 10 minutes. So within 10 minutes, anything that this client sends to the upstream will end up in the same upstream. And I would actually have to say that this is not the total time limit. This is the minimum time that we have to see a packet. It's the maximum time between packets that we will wait. So if we don't see anything from the client for 10 minutes at all, then we would actually forget about this connection information. And then next time, if the client comes again, it would actually be a new connection, and it might be load balanced onto a different upstream. Right? So I just kind of want to emphasize it because of the nature of UDP. We just don't have a reliable way to tell if the transaction has been finished. So we just have to use some kind of time limit for remembering the UDP transaction information instead of like TCP, because of the explicit handshake and and the finalization for TCP. We always know whether a session is still active or not. But for UDP, we just have to guess, and we guess it. If it's too long and we don't see anything, we just assume the connection is dead. So that's my demo for today. And if there's any other questions, feel free to ping me on Slack. And once the 2.2 alpha is out, please give a try to this feature and tell us how do you think about it. And that's my demo. Thanks, everyone. Bye.
Yeah, and okay, so that was the, oops, my cat is destroying my stuff. Sorry about that. And yeah, so yeah, if you have any questions about it, feel free to post it on the chat, and we'll get to them later. Let me get back to the presentation here and talk about the rest of the 2.1 stuff. So other things that are also coming in Kong 2.2 Alpha 1 is rate limiting by path is one of the limit by attribute, and the rate limiting plugin now supports path as an option. So that was a community contribution. Then we cleaned up the PR, added the tests, and made it go through the finish line to get that included in Kong 2.2. Also, Kong now produces and respects, when coming from a trusted source, the X forwarded path header. That was it's also an addition in 2.2. Related to that, there's a new PDK function, Kong.request that get forwarded prefix, in order to read that information for the path and for the prefixes. The Kong.log.serialize function was also extended for supporting streams to make sure that all of our logging plugins support TCP and UDP and provide the information correctly. And the gRPC web plugin was extended to support handling the same behavior of script path that our routes support. So that's also already in and coming in Kong 2.2 Alpha 1. And more stuff is on the way as we are hard at work and building things that we want to get into 2.2. So one of the things that's in the works right now and coming is support for having a configurable setting for request or response buffering and make it configurable per route. Usually that, like before, that was enabling request buffering or response buffering was something like of a global setting that's what you get, for example, from Nginx. But with Kong 2.2, you should be able to configure that on a per endpoint basis. So on since Kong 2.0 and especially in 2.1, we have been pushing this new hybrid mode in which you can have database-backed control plane nodes and DB-less data plane nodes that coordinate between each other, where you can have your admin API on control plane nodes that talk to a database, and you can have data plane nodes that do not use a database at all and respond to the proxy requests. And for 2.2, we are working on some API improvements for the status endpoint, so you can have a better view of your data plane nodes from your control plane nodes. And also, we have made some significant performance improvements on the synchronization, and this is going in 2.2, not 2.1, because it changes it has to do with the internal communication between the CP and DP nodes. So this was something that fit in 2.2 better. Also, we have a pipeline of work on future improvements for load balancers. So we are working on like internal refactors for that and looking at some possible features that we want to get. I'm being purposely vague on this one because it's very much work in progress, and I don't want to vaporware anything for 2.2 because if it doesn't get ready for 2.2, we're getting it into 2.3. But we're looking at things such as integration with service discovery services like console, and I would very like much to hear people's impressions, whether this is something that we should further pursue, like to have like a more direct integration with service discovery tools. And yeah, and generally we're laying the groundwork with internal refactors and things like to make the upstreams and targets more amenable for adding new features in the upcoming releases. So one of the things that we are looking into is removing the target history that gets stored in the database for Kong in order to perform consistent hashing. We are changing the consistent hashing algorithm so that you can still have that without a target history stored, because that target history was always a bit of a pain in which you have to periodically clean it up, and that was if you make lots of changes in your targets, that was really like not an optimal way of doing it. And now we are working on that, and we hope to have some news in future releases. This is not going to be in the alpha, but this is a thread of work that we are that we are looking at and working on right now within the core team. So more stuff in the load balancer will be on the way. And of course, when we talk about like stuff that's coming for new features, I guess another thing would be, well, possibly your contributions to Kong 2.2. We've had a bunch of new features coming in Kong 2.1 that came from the community, which we have then like reviewed your PRs and got them merged and in shape for release. So yeah, so if you have any ideas and contributions and things that you want to improve Kong with, make sure you send us a PR and nudge us if we don't respond quickly. We try our best, and we'll look into getting that included as well. So yeah, that's all that I had for today, and open for questions. Whether you want to just unmute yourself and ask questions, or through the Zoom chat, feel free. And also, I have a question that comes from us from Kong open source development team. So from all that was presented here and that we've been talking about, what are the features that you're most excited about? And we like feel free to comment on the chat and give us feedback on any shape or form. We're also in Cognation, we're very much eager to hear feedback on this, because we develop the features as we feel that there is demand for them. And so that's really important for us. So yeah, so thank you. And now we'll stop sharing. And if there are any questions, we'll hand over to Caitlin.
Awesome. Well, thanks, Hisham, for the awesome presentation again. And thank you everybody who joined us today. The only other thing I just want to mention is we have more exciting announcements and product updates coming out at Kong Summit, which is happening on October 7th through the 9th. We also have workshops happening there if you're interested in kind of diving into Kong Gateway or some of our other projects a little bit more. So I'm going to drop the link in the chat. Tickets are free this year. It's a virtual event, so I'm pretty excited about that. And I hope to see you all there. Our next online meetup will actually be the week after this in October. So we'll have some updates there as well, I'm sure, coming out of Kong Summit. So thanks, everyone.